So I'm having just short of about 30 minutes to solve the problem today. Let's see. We are given a matrix, which is a list of what? Strings or integers? Integers. Okay, and we have a target, which is also an integer. And we need to return the number. This is also an integer. That's sum to target, okay. Okay. So challenges before we start with tests. So there are a submatrix is defined by corners, and there are two corners for each. There are n times m ways to choose the first corner, and then n times m ways on average to choose the second corner. So it will be n squared m squared runtime for root force if you just want to iterate over all possible corners, and that's at best, because we will also theoretically need to sum all the numbers inside the matrix. So maybe like if we just choose two corners and then sum everything inside the matrix, that will take even longer. Okay, so now let's see, is it always matrix? No, it can be different numbers, and targets can be different. I just saw that there are zeros and ones in the test they're showing. Okay, so let's create some tests. I will mark an idea that I have here as a possible solution. Prefix sums for rows and columns, but I don't know if it will work or not, so let's try and see. Okay, let's have something like 0 1 1 0 0 2, and let's say that the target will be equals 2. Let's count the number of matrices. So this will be one matrix like this, and this will be another one, and this will be like this vertical to 0 will be another one, and then the 2 itself will be yet another one. So it will be 4 matrices, I think. Let's just, for the sake of clarity, calculate the number of matrices with some negative number. Okay, this turned out to be a little uglier than I should have thought about this, but yeah, let's see. This is -1 0 1 0 2. Let's say our target is actually 0. Target equals 0. So it will be 1 2 3 zeros by themselves. Also these big matrix, also 4. Okay. So the solution, prefix sums, right? So what I'm thinking about, what I was thinking about was that, let's say we have a calculation here, and we now need to, like, we have this matrix, and we now want to add a row, right? So to add the row, we will need to add the whole row between two integers. And for this row between two integers, I mean between the start and the end of the row. And how much we will be adding will be defined by this prefix sum. So if we have a prefix sum for the row, we can calculate how much will we be adding by adding this particular row for this particular matrix. So if we already have a specific matrix calculated and we have prefix sums for rows and columns, we can calculate adding like new row and new column very easily in O1 essentially. But what else can we do? So what if we want to calculate a sum between two corners, right? So let's say I will iterate over all possible corners. Can I find this like in a faster than n cubed m cubed? Like, can it be n squared m squared? Can I be clever about how I calculate this? So let's say that for each element of the matrix, we will calculate the total sum of everything to the bottom and to the right, and to the top and to the left. So let's try to draw this, right? So let's say we have something like okay, and here let's say we start overlapping. And then we have this. Okay. So what I'm trying to show here, right? We will have, like, let's say for this corner, we'll have the sum of all these elements calculated, right? Then for this corner, we will have the sum of all these elements calculated. Then for this matrix, yeah, we will need to do some manipulation with like 6 numbers, right? Okay, so first of all, how much do we need to add for this Y matrix? So yeah, I actually think that we don't need, we just need to calculate, for example, everything that is, like if this is a corner, everything to the bottom and to the right of it. So then how do we calculate this Y piece? We add, we get everything from this corner to the bottom and to the right. Then we subtract everything from this corner to the bottom and to the right. Then everything from this corner to the bottom and to the right. And then we finally add back this corner to the bottom and to the right. And we will need to create this matrix of like dynamically use some dynamic programming kind of to calculate this matrix, and then add zeros to as the right column and the bottom row, and we will be able to calculate everything in of n squared times m squared. So that's okay-ish. Can we do better than that? I will call this prefix because it's not really a prefix, for all cells for the cell is top left corner. Yeah, and then in such case we will be able to calculate everything. So then we just choose each of the corners and then we start iterating overall possible corners. Yeah, n squared m squared. So then can we do it better? Is there some kind of pattern that we have seen for target sum, right? Basically two sum problem. So in two sum problem we are storing the complements we are storing the complements in the dictionary. So what I'm thinking about, can we also store complements in dictionary? Like, can we store how many ways do we have to get to some target? So let's say we have this corner, right? This corner. We know the total sum to the right and to the bottom. And there are all these matrices here. But for each of those corners, let's say we choose a combination of, okay, yeah, we basically need to choose the other corner, right? And then this other corner will create what? A combination where we so let's say this is the corner that we need to remove, right? Like all of these z values. How much are we removing in this way? Can we calculate like for all possible values what we will be removing? I'm not seeing how we can do that yet. Because for this corner we'll have like, okay, let's say we have stored, we know that, for example, the target is 10 and this whole sum is 5. Okay, this whole sum is 20. Now it means that we need to find how many ways are there so that a block like this and a plus a block like this sum to minus 10, sum to 10, right? So for example this and this block, this block, Let's check how big are our n and m. Okay, yeah. So it's 100 by 100. So it's 10 to the power of 8 if it's of n squared m squared. So we should find a faster approach. Given that we know the target, it should be possible. Something should be possible. Does it help to also calculate the sum as like bottom right corner? So let's say we are calculating it by columns and rows, right? So everything is always like a column like this and a row like this. So we can start calculating the number of ways that for each of the coordinates in the matrix that can be 100 by 100. We would like to know for each of those coordinates how many total ways are there to get to a specific sum. So then we just need to understand how to calculate this, how to like iterate over all possible corners here, right? So let's say this is the corner. Then, yeah, for this corner, there are all these possible corners. But for this corner, there are also all of these possible corners. So we can just store for each of these second corners. But the thing is that, yes, it's not enough that we have a second corner. We should have like a triplet. This one, this is 1, this is 2, this is 3. Is it triplet though? We have this coordinate. We have for this corner we have 2 coordinates. we need another two that can be anywhere here. So let's say we are iterating from the top bottom, or from the right bottom, and going to the top, to the left, to the top. And we for example, here there is like 0 ways to get anywhere. There is one way to get to some number, another way to get to some other number, another, and then we do the same thing for like iterating to the top, to the top, to the top. So this will be of n times m operation. And then we do the same thing iterating by column. So how many ways are there to get to a specific target for this column, for this, for this, for this, up to a specific number. So then we are here. What we can do, we have how many ways are there to get to a specific target if you use everything up to here, right? Because we have iterated. So we just calculate the prefix sum. So this whole, this whole thing, how much will it be? Yeah, I don't know. I have just 10 minutes left or fewer, so let me just try to implementation. I want to do a simplified implementation of what I was trying to propose, because it's better to write something than to just never-endingly spend time here. So okay, for all in okay. Total sum from the bottom to the top. Yeah, so okay, it's late today. I'm too tired to implement this. Should try earlier tomorrow, but for now I'm done. And we'll review the solution afterwards, after this meeting. There is definitely some combination of like tweaking and hashing that I couldn't come up with. Maybe if my mind is fresher, I could have come up with something, but okay. Of n squared, m squared solution is the best that I can do. And I won't be implementing this in the last 10 minutes.